Okay, we're going to switch gears a little bit compared to what we have been doing in the first couple of chapters, and we're going to right now do some reviewing of the distance formula and midpoint formula and applying those to a couple of problems. Now remember, the distance formula is really a special case of the Pythagorean theorem, where the distance between 2 points is really your hypotenuse, and you could just use the Pythagorean theorem. But if you solve it for any two particular points, it's really the difference in your two x's all squared plus the difference in your two y's squared all inside of a square root. So if we want to find the distance for these 2 points here, and by the way, this d parentheses ab means distance between these 2 points, we want to subtract our two values of x. Because of the squaring that we have here, the order in which you put your two values of x in does not make a difference. Then we also want to go ahead and subtract our two y values. And then you want to go ahead and square the difference in your x's, square the difference in your y's, and get this. Then you can add them together. Then it's just a matter of seeing if your root simplifies. In this case, it does. It's a 25 times 5, and the square root of that 25 is really nice because that's just a 5, still leaving this 5 inside of our root. Midpoint, on the other hand, is just the average of the two x's. Remember, average, you add things together and divide by how many things you added together, because average is your middle, and midpoint is right in the middle. So we got to add the two values of x, and the order in which you add or put the x's in here doesn't make a difference because you're adding. Same idea here with the y's. And so then we get 19 over 2, and then we get 0 over 2. You could write your 19 over 2 as a decimal since it ends up being a nice, neat decimal, but fractions are perfectly fine and encouraged. So here you're asked to find a perpendicular bisector between these 2 points. And we're asked to find the equation that relates that x and y, that perpendicular bisector, which happens to be a line. Now, a perpendicular bisector means it's a line that cuts the segment AB in half. That's the bisect part. And then the perpendicular part means it forms a right angle. Well, bisect means it goes through the exact center, which would be your midpoint. So all we have to do is find the midpoint of these two here. So we'd have to add together the x's, divide by 2. Add together the y's, divide by 2. So then we get 1 over 2, and then we get negative 7 over 2. So we know it has to go through that point. The perpendicular part means slopes of perpendicular lines are opposite reciprocals. So if we find the slope between these two, the slope that we're looking for that's perpendicular would have to be the opposite reciprocal. So let's go ahead and find the slope between these two. Remember, with slope, you need to go rise over run, which is difference in the y's over difference in the x's. So I took this y value first, so for the top, and so then when I'm doing the difference in the x's, I got to take this value of x first. This value of y was second, so this value of x has to be second. So now we simplify the top, simplify the bottom, we get 1 over negative 9, or negative 1/9. That's the slope going between A and B, but we want the perpendicular, so that means it's the opposite reciprocal. So you got to flip the fraction upside down and switch the plus or minus sign in front. So we get a slope of 9. So we're looking for a slope that goes through this point, or not looking for a slope, looking for a line that goes through this point right here, and it has a slope of 9. Well, if we have a slope and a point, we might as well use our point slope formula, which is y minus the y value of your point equals your slope times x minus the x value of your point. So we can take our slope of 9 and plug it in for m. Take our point, plug it in for your x1 and your y1. Then all we have to do is try to get y by itself. On the left-hand side, you're subtracting a negative, so you know it's plus. Right-hand side, we could distribute through, and then we could go ahead and subtract a 7/2 from both sides. And then this would be the equation of our perpendicular bisector. Here, you're given that C is the midpoint of AB. We know what C is, and we know what A is. So I think it's easiest to go ahead and look at this graphically. Could you use your midpoint formula? Yes. But if we look at it graphically, you have your A over here in the lower right. You have C here. So based on C being in the middle, you would know you'd have to come up from here, and then that B would probably be somewhere up here, roughly speaking. So we have an approximation just from looking at the visual. So now you should be able to see that looking at your A, you were at 5 for your X, then you go to C, which is at 2. So to go from A to C, you went left 3. Well, since C is the midpoint, it's got to follow that pattern going on the other side to get up to B. So if we were at 5, went to 2, we went left 3, we'd have to go left another 3, so that means B would have to be at -1. We can follow that idea also looking at the y's. From A up to C, we're at -7 and went up to 3. That's going up 10. To go from C up to B, we'd have to go up another 10. So if you were at 3, went up another 10, that puts you at 13. In other words, the coordinates of B is -1, 13.